Today I'd like to talk about the payback period. In previous lectures we've looked at a number of different methods for evaluating alternatives. We've looked at present worth method, annual worth method, internal rate of return. And all of these are very commonly used. But actually the most commonly used one is what's called payback period. And it's kind of special because it doesn't take into account all the mathematics we've been learning. What it is, it's a rule of thumb. It's a rule of thumb that has very little basis in theory, but actually works quite well for most engineering problems. And you'll see it being used a lot. And the idea of a payback period is quite simple. What we do is we recognize that most purchases involve a first cost followed by savings afterwards. So you buy a new piece of equipment for the plant floor, and this saves you money. And what you want to do is pay back that first cost by the savings. So if it costs $100 and it saves you $50 per year, intuitively you'd say that $100 is paid back in 2 years at $50 per year. And now that doesn't make any sense, based on the mathematics we've learned and the whole logic of interest. Because of course that $50 doesn't occur at the same time that the first cost does. But that's fine. We'll just ignore interest. We'll imagine interest is zero. And if you like, that's a way of dealing with the payback period is to make the approximation that interest is zero. So to calculate the payback period, we divide the first cost by the annual net savings. That gives us a number of years. To determine whether we want to buy something based upon the payback period, the rule is as follows, by and large. Less than 2 years, you buy it. 2 to 4 years, you buy it if you have a government grant to buy it. More than 4 years, you don't buy it. Now, that's a rule of thumb, again, depending on your company. If cash is really tight, you might have a rule that only buy things with a payback period of 6 months. I've seen it as short as that, or 3 months. Or if there's lots of cash around, you might extend it beyond 2 years. To compare alternatives, generally the one that has the fastest payback period is better. So it's a very simple calculation, very easy to do, and quite often done. Let's look at an example of doing this. We've got a new packaging machine, saving Waterloo cheese, $3,000 per year, in reduced spoilage, $1,000 per year in packaging material, and $2,500 per year in labor. We'll have additional expenses of $700 per year in maintenance and $200 per year in energy. If it costs $20,000 to purchase, what's its payback period? So what we want to do is take our first cost of $20,000 and divide it by the annual net savings. Now we've got a bunch of different savings here. We've got $3,000 for spoilage, plus $1,000 for packaging material, plus $2,500 in labor, minus the additional expenses of $700 in maintenance, minus the $200 in energy. So this down here then is the net savings. That's $20,000 divided by 5,600 equals 3.6 years. So by my rule of thumb, you probably wouldn't want to buy this because it takes so long to pay back. On the other hand, if there's government support for it, you would. Now the idea behind the government support is that there are lots of government grants available for buying equipment. If the government looks at a project and has a payback of less than 2 years, they'll say, well, the company should be able to afford to pay this for themselves because the payback's so quick. If it's that's less than 2 years. If it's more than 4 years, the government will say, well, the payback's too long, we won't get a return on this investment that's justifiable. But between 2 and 4, that's the range that the government grants tend to target for. So if you did a payback period analysis of this kind of a problem, you'd say, well, perhaps I should see if this fits into a government grant program to help pay for this investment. So you can see the calculation here is really easy. No interest rates, no transformation factors, just simply addition and division. And it gives a pretty meaningful result. A lot of advantages to the payback period. One is very easy to understand. You can communicate this to unsophisticated managers or other people without having to to justify the complex mathematics you get with other techniques. It's very easy to calculate, which is an advantage. You can do a very quick calculation. It's also good enough for most purposes. All of the comparison methods we've used require this assumption of being able to predict the future fairly well. And in fact, the future is pretty fuzzy. We don't know what sales will be like. We don't know exactly what kind of breakdowns the equipment will have. We don't know what contract the union's going to be able to negotiate next year. And so our future estimates are often very fuzzy. The payback period says, well, since we don't know for sure anyhow, why don't we have an approximation, and that's good enough. It also takes into account the need to have capital recovered quickly. What this means is if you have a project that has savings 20 years from now, that's so far away that even though they might be very large, it's really hard to justify taking them into account because the company may be out of business in 20 years. You want to have your capital recovered quickly. In other words, you want to have your savings done quickly, and the payback period takes that into account automatically. Of course, disadvantages is that because you're not discounting the cash flow, you're not using the interest rate, your answers can be wrong. And another disadvantage, which I'll demonstrate in a minute, is that it's not always correct because the service life is not taken into account. The service life is not taken into account. And I have an example to demonstrate this last point, where Waterloo Defense Systems wants to upgrade their paper shredding facility. They have a choice between two alternatives: a Model 007 at $5,000, which saves $10,000 per year, or a Model MX at $10,000, saving them $1,500 per year. We have different expected lives: the 007 of 7 years and the MX of 20 years. And we're given an interest rate, which is the better buy. One way of assessing the better buy would be through the payback period. So using payback period, for the 007, we've got $50,000 first cost, $10,000 savings, equals 5 years. And then for the MX, we've got a $10,000 first cost and a $1,500 savings, and that's 6.6 years. And even though these are both clearly beyond our 4-year threshold that I mentioned before, because the 007 is paying it back more quickly, we tend to choose the 007. Now, of course, we were given an interest rate here of 8%. We didn't use that for the payback period. We don't need to. We can, however, do the same calculation for, say, an annual worth comparison to get an accurate measure of which one of these is better. For 007, we've got the $10,000 savings per year minus the capital recovery of $50,000 spread over the 7-year life at 8% interest is $396.50. And for the MX, we've got a $1,500 savings and a $10,000 first cost spread over the 20-year life at 8%, and that's $481.50. So in this case, because this is worth we're looking at, the one with the highest present worth is the MX. It's the one you'd choose. Now, the annual worth comparison method is, in a sense, more correct because you're properly discounting these future payments. And the payback period is not. But in this case, the difference is not due to the discounting so much as the extra life of the MX. Now let's look at this closely. With the MX, its expected life is 20 years. However, the payback period is 6.6 years. So in the payback period, the first cost of $10,000 is paid back in 6.6 years. And all the savings thereafter for the next 13.4 years are ignored. They aren't taken into account. With the 007, the payback period is 5 years. And then there's only 2 more years of life in which the savings are accrued. So the vastly extra life the MX has is ignored. The MX could have had a life of 7 years, could have had a life of 6.6 years, and these calculations would be the same. Or the 007 could have had a life of 5 years and it would be the same, because it doesn't take into account the life beyond the payback period. And because the MX has so much extra service life, that extra service life contributed more savings in the annual worth comparison to show that it was substantially better by almost 25% than the 007. So this is something you have to be aware of when you're using the payback period. Payback period is a wonderful technique for very quickly assessing the benefits, the worth of an asset purchase, even comparing asset purchases. But you've got to keep in mind that service life. Also keeping in mind that you aren't using discounting, and if the interest rates are fairly high, then that can have a significant effect too. Thank you.